Hello and welcome back. In this session, we are going to discuss the concept of tokens used in blockchain very briefly through this toy example. Tokens are the way by which you can convert an asset into smaller divisible chunks. Imagine that you want to own a piece of pyramid or the Great Wall of China or Taj Mahal of India. It's virtually impossible to divide all these large artifacts, which are basically assets, into smaller divisible forms and distribute the ownership among multiple people. Concept of tokenization helps here, where you can represent assets in the form of tokens which are divisible, and these tokens can be owned by multiple people. So concept of tokenization is used extensively in blockchain, and that helps in establishing partial ownership of assets and attributing ownership of a large body of asset to multiple people. You can imagine what kind of facility it will have when you are distributing land or properties and distributing the ownership of such big assets among multiple people. I'll discuss about this in more detail in later part of the course, but here is a toy example where you see that different people, they are transferring money from one person to another in the form of tokens. Because blockchain can store these transactions which are happening through tokens, all the features of blockchain will be applicable here. For example, if for some reason Capta wants to claim that he has actually transferred not 867 but 868 units of dollars to Strass, that will easily get noticed. The fact that Capta is trying to change the data in the blocks, because all other subsequent blocks will become inconsistent, and even if Capta tries to mine these blocks and make it consistent, this data will not match with the blocks that are available in the other peer nodes, and the other peer nodes will outvote this particular peer node which is inconsistent. This is what we have also seen as a part of the distributed form of ledger. So you can see that how tokens can be easily managed in blockchain. This toy example does not mention what was the source of this token, from where this token got generated. In this particular case, the dollars or the tokens, from where they got generated. In case of blockchain like Bitcoin, there is a transaction called coin-based transaction. You might have noticed this when we are observing the Bitcoin transactions. And this coin-based transaction usually denote the source of any creation of any token. In this particular case, you can see that the coin-based transaction ensures that there is a $100 token earned by Anders. We are not questioning here how did Anders earn this dollars. In case of Bitcoin, the miners earn these dollars through mining, and that's why the coin-based transactions represent the reward, the block reward and the fee reward that the miners earn. In this particular case, this may be earned through some other means. In case of fiat currency, like a dollar or a rupee or a yuan, it is usually the government which has the authority to print money. That's how the money is getting generated, and then this government gives this money away for circulation. So these are the sources of the money, and once this source is established, then from this source, Anders can now transfer all the money to different people, and these different people can then transfer the money subsequently. Now, obviously, Anders cannot transfer more than $100 to any of these people. Now, is this possible here? let's say we change this to 95, which means that Anders is transferring $95 to Madis, and along with that also transferring $10, $20, and $15 to Sophie, Lucas, and Emily, respectively, which is obviously cannot be true because Anders only has $100. Now, does this play blockchain stop this from happening? Let's try and mine this, and let's see if it stops the process or invalidates the block. You can see that this block did not get invalidated, and we can go on mining the subsequent blocks to see if we can generate valid blocks, or at any point of time, does any of these blocks show that there is a problem in this entire transaction, because the amount that has been transacted out is more than the amount that Anders has actually earned. Now you can see that the second block also doesn't prevent this, nor did the third block. And let's see the fourth block, whether it does something, fifth block rather. And you can see that there's varying time of mining, and you see that there is none of the blocks actually said that this is not a valid transaction. While mining, this was not found out. Now, this will not be the case in a real Bitcoin kind of a blockchain. This is this is happening in this toy example, because this particular check is not inbuilt in the algorithm. But obviously, this is not going to happen in a real blockchain application like Bitcoin. And that's where the concept of unspent transaction output, which we'll discuss in detail at a later point in one of the later sessions, will come in. The concept of unspent transaction output will ensure that the total number of transactions that are going out from Anders cannot be greater than the amount of tokens that Anders already possesses.